Today we're going to talk about secant and cosecant. And yesterday when we were doing, looking at our triangles on the coordinate plane, we saw the abbreviation for cosecant, which was CSC. We saw the abbreviation for secant, which is SEC. And secant and cosecant are the reciprocal functions. Secant, let's start with cosecant. Cosecant is the reciprocal of sine. And let's take a minute and fill in a couple of these values. Sine of 0 is 0. Hopefully on your quiz that you just recently took that you got that correct, if it was on your particular quiz. Cosecant is the reciprocal of that, which means that we're going to have 1 divided by 0. And hopefully you're better than me. You left a little bit of space to write in the fact that what does 1 divided by 0 equal? And what I like to say sometimes is that 0 is underneath. So when it's underneath, it's undefined. I'm going to write right on top of that. So the cosecant of 0 is undefined. But if we think about our hand gestures, and I know that you can't see the hand gestures on the video, but if we do sine of pi over 6, that's going to be our ring finger. We're going to fold that in. When we fold that in, we've got 1 finger below here. So the sine of pi over 6 is 1/2. So when we're looking particularly at the cosecant of pi over 6, we're going to take the reciprocal of that value, which is 2 over 1, or also we could just say 2. If we look at sine of pi over 4, again, using your hand gesture, which you can't see on the video, but that's going to be our middle finger. If we fold our middle finger in, below our middle finger we have 2 fingers, so the sine of pi over 4 is the square root of 2 divided by 2. And the reciprocal here, just wait a minute to fill it in because I want to simplify it and you don't have enough space on your paper to fill this in. But the reciprocal of the square root of 2 over 2 is 2 divided by the square root of 2. Again, you probably don't have space to write this on your paper. Maybe at the very top if you want to write it in, or at the very bottom. But we want to get rid of the radical in the denominator. So we're going to multiply by radical 2 over radical 2. We're multiplying by a fancy form of 1. And 2 times the square root of 2, when we multiply the tops together, 2 times the square root of 2. Square root of 2 times square root of 2 is square root of 4. And what does the square root of 4 equal? 2. So we get 2 times the square root of 2 divided by 2, and we actually can simplify that a little bit more. Those 2's cancel out. So we get the square root of 2, which is our reciprocal of the square root of 2 over 2. And I know you didn't have enough space, but as we work through these kinds of problems, I will show my work to make sure that we know how to rationalize a denominator. When we look at pi over 3, again, using the hand gesture, that's going to be our index finger. So the sine of pi over 3 is going to be the square root of 3 over 2. Once again, wait a minute, because the reciprocal of the square root of 3 over 2 is 2 divided by the square root of 3. And once again, just like the tangent, we need to get that radical out of the denominator. So we're going to multiply by the square root of 3 over the square root of 3. Fancy form of 1. So we multiply the tops together, we multiply the bottoms together, and we get 2 times the square root of 3 over the square root of 9. Square root of 9 is actually 3. And that is going to be the reciprocal of our value up here of the square root of 3 over 2. It's going to become 2 square root of 3 over 3. One more value here as we look at sine of pi over 2, quadrantal. Our hand gesture doesn't work quite as well on this one, but the sine of pi over 2 is 1. Well, what's the reciprocal of 1? Still 1. The thing to remember, the reciprocal of sine is cosecant. Now when we look at the reciprocal of cosine, it's secant. And it's an odd way to remember things, but it's something that's stuck in my head. Maybe it'll work for a couple of you. It's SC. Sine cosecant. Secant cosine. SC or CSCS. So they go together. They're both CS's. So when we look at the cosine of 0, and I probably should just draw a brief picture here. Again, this isn't going to fit on your paper, but cosine of 0 is at that point roughly there. Remember, the ordered pair of that point is 1, 0. And the cosine value is going to be the x value, which is 1. And once we determine that, then we can figure out what the secant value is by taking the reciprocal of 1. But fortunately, the reciprocal of 1 is 1. A little bit easier to do some of these others. Cosine of pi over 6. If you recall, when we did this, again, the cosine of pi over 6, we're going to be folding in our ring finger, but now we're looking above. The cosine of pi over 6 is radical 3 over 2. And we've already calculated the reciprocal of that, including getting rid of the radical in the denominator. And what we ended up with is this black work down here below the chart. It's going to be 2 radical 3 divided by 3. Cosine of pi over 4, that's going to be our middle finger. We've got 2 fingers above there, so the cosine of pi over 4 is the square root of 2 over 2. And once again, we did that calculation already. It is in red underneath our chart, but we see that the reciprocal is going to be 2 over the square root of 2. But when we rationalize, we end up with the square root of 2. Cosine of pi over 3, again using the hand gesture, which you can't see on the video, but the cosine of pi over 3, we're going to fold in our index finger, and we've got 1 finger above there, so this is going to be 1/2. And we know that the reciprocal of 1/2 is 2. We're flipping that fraction. Lastly, cosine of pi over 2. Well, cosine of pi over 2 is at this particular part of our unit circle. The ordered pair at this point is 0, 1. So the cosine is the x value of that ordered pair, which is 0. And if we take the reciprocal of 0, we saw that back at the very beginning, 1 over 0 is undefined. So there's the values of cosecant and secant. Again, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And I think of them as CSCS. So I may have gotten a little bit redundant here on this page that's at farther down in your notes. Not to the left here. Sine and cosecant of theta. Well, I want to go backwards for a moment here. In our last set of notes, when we were talking about the triangles in the trigonometry, we talked about all students take calculus, and it actually wasn't in those notes, it was in the previous notes. But we were learning some techniques to help us remember things about the unit circle. And what we said is, all students take calculus. And what that means is that all functions in the first quadrant are positive. And that includes cosecant, secant, cotangent, along with your sine, cosine, and tangent. In the second quadrant, sine. All students starts with S, sine starts with S. Sine is going to be positive in that second quadrant. And we can go back now and we can fill in this chart up here. Sine is positive in quadrant 1, and it's also positive in quadrant 2. And consequently, it's going to be negative in the third quadrant, which is the T. Take tangent. Tangent is positive in the third quadrant. And cosine calculus is positive in the fourth quadrant. So negative in the third and the fourth quadrant. We can look at secant and cosine as well. Cosine, we know, is positive in the first quadrant because all of our functions are positive in the first quadrant. But all students take calculus. Over here in the fourth quadrant, that C indicates that cosine is positive in the fourth quadrant. And consequently, it's going to be negative in the other two. Quadrant 2 and quadrant 3. That wasn't the redundant part. It's redundant here. I only listed sine and cosecant. I think that my intention originally was to do the rationalizing here, where we have a teeny bit more space. But ultimately what I'm doing is I'm looking back at our chart. When sine is 0, we take the reciprocal and we get undefined. When we're looking at the cosecant. When sine of theta is 1/2, our reciprocal is 2. When sine of theta is the square root of 2 over 2, when we take the reciprocal, we get 2 over the square root of 2. We have to rationalize that value. And ultimately what we ended up with is the square root of 2. When sine of theta is the square root of 3 over 2, then cosecant is going to be 2 over the square root of 3. And when we simplify that, I have to look at this one, 2 radical 3 over 3. And finally, when sine is 1, the reciprocal of 1 is still 1 for our cosecant value. But what I want to take a look at here, and we won't get it completely filled in, but what we're given on this remaining part of our front page of our notes is we're given a unit circle. And what it says to do is it says fill in all the secant and the cosecant values. But what I want to point out to you again is that I'm going to start with cosecant, and that's as far as I'm going to get. But when we're dealing with cosecant, if we know the first quadrant values, the only thing that's changing is whether the value is positive or negative when you're in the second quadrant, whether the value is positive or negative in the third quadrant, whether the value is positive or negative in the fourth quadrant. I had to write very, very small to fit this in. Maybe this isn't the place to do it. Maybe you need to take one of your big unit circles and fill it in. But I'll show you my approach here. And the first value here is going to be cosecant of 0. Well, we just talked about cosecant of 0, and cosecant of 0 is undefined. I'm going to write UD because I can't fit it in for undefined. Then cosecant of pi over 6, well, it's the reciprocal of 1/2 is 2. We've just seen it. We've done them a couple times. And cosecant of pi over 4 is the reciprocal of the square root of 2 over 2, which ultimately simplified to be the square root of 2. And cosecant of pi over 3 is the reciprocal of the square root of 3 over 2, which is 2 over the square root of 3. And when we simplify that, we get the 2 radical 3 divided by 3, cosecant, if I can write it, cosecant of pi over 2 is the reciprocal of 1, which is 1. Now, when we get to the second quadrant, the cosecant of 2 pi over 3 is the reciprocal of radical 3 over 2, which is 2 radical 3 over 3. And the cosecant, and I hope you're even going faster than me, of 3 pi over 4 is the reciprocal of the square root of 2 over 2, which when we rationalize that is the square root of 2. And the cosecant of 1/2, the cosecant of 5 pi over 6 is going to be the reciprocal to 1/2, which is 2. And notice that cosecant is related to sine. Sine is positive in the second quadrant, so cosecant is positive in the second quadrant. Then we get to the quadrantal. Cosecant of pi is going to be the reciprocal of 0. The reciprocal of 0, again I'm going to write UD for undefined. As we get down here into the third quadrant, cosecant of 7 pi over 6. Notice that our values haven't been changing, and in fact they've all been positive so far. But now when we take the reciprocal of negative 1/2, we're going to get negative 2. When we take the cosecant of 5 pi over 4, we're going to take the reciprocal of negative the square root of 2 over 2, which is going to give us negative the square root of 2. And cosecant of 4 pi over 3 is going to be the reciprocal of negative the square root of 3 over 2. When we simplify that, we're going to get negative 2 radical 3 over 3. And to finish our unit circle here, the cosecant of 3 pi over 2 is going to be the reciprocal of negative 1, which is negative 1. So our values here should look familiar. 2, square root of 2, 2 radical 3 over 3. Same numbers, just different signs. And that's what's happening as we finish. Cosecant of 5 pi over 3 is going to be negative 2 radical 3 over 3. Cosecant of 7 pi over 4 is going to be the reciprocal of negative the square root of 2 over 2, which is going to be negative square root of 2. Cosecant of 11 pi over 6 is going to be the reciprocal of negative 1/2, which is negative 2. And when we come full circle here, cosecant of 2 pi is still undefined. What you can work on is you can work on filling in the secant values. I know you had to write very, very small on this, and maybe you want to get a bigger unit circle to write on, which you, I think, should have a spare copy in your notebook.